All right, so let's start with a quick demo, see what we're going to build today. So here we have an AI agent that is able to search our tweets with the GraphRAG. So let's ask a question. Who are the users that talking about Python? And here we have this response of 17 seconds. So that several users are discussing Python and data science and also automating workflow. And here are those tweets, and also here are the users. So we have those 3 users that discuss about Python. And if we expand this thinking process, and we can see in this query, the AI agent used 2 of those tools. The first one is a vector search, so find out all the tweets that is similar to the keyword of Python. And then after we have those tweets, and we did another query where we find out users that who posted tweets with those IDs. So as you can see, AI agent can automatically decide how to search the database, retrieve the correct information, and also give us a complete answer. So if you followed our previous tutorials, you know that we have created a free Neo4j instance where we stored our tweet data in this graph, where users send out tweets. Tweets can be located in different places, and also tweets can contain multiple hashtags. So in our previous tutorial, we introduced how to create embeddings with the Gemini embedding model, and also we used a free API. And then we demonstrated that how we can perform a GraphRAG. So based on the relevant tweets that we identified from those embeddings, we can expand our search to include the user information, place information, and also hashtags. And we also demonstrated that we can also ask AI to help us write Cypher queries. So for example, if you want to ask how many tweets per city and also who are the most popular tweet users, so users can ask that question in natural language, and the AI can convert that question into a Cypher query and also retrieve the most accurate response. And finally, we also defined these geospatial queries in our previous tutorial. So where we can filter tweets by locations, and then we can perform the vector search and also expand to the graph search, and finally pass all the returned results to large language model and also get the precise response. And however, the problem of our previous tutorials is that number 1, it does require Python coding, and number 2, all the tools are separate. So that if you want to do a specific search or query, you have to decide which tool you are going to use. So the benefit of this AI agent is that the agent can perform those queries and also decide which tools we are going to use. So today, we're going to build this agent from scratch, and it is complete free. And also the best part is that it does not require any codings. So AI will handle the workflow and also decide which tool to use. Okay, so let's get started. I am using a free instance on Neo4j, and it now has this AI agent function that recently been released. So we can go ahead and create an AI agent. So we can create with AI. And here you are going to choose which instance you're going to use. And of course, we need to tell AI that we do have the embedding in our database. So right now, they support either OpenAI or Google. So let's use Google Gemini AI embedding. And we use a Gemini embedding 001. Okay, so this is where you can provide a prompt that asks AI to create this agent. So specifically, you should tell AI that the structure of the graph and also what kind of task you want AI to perform. Okay, so to create that prompt, we're going to use another AI. If you're using Chrome, and you can see Chrome now has a function called Open Gemini in Chrome. So let's bring Gemini here. And here we're going to provide the background. So here we can see that Gemini is not able to access those 2 pages. So this page is where we define the embeddings and also graph structure. And this is a page that we're going to create this AI. So let's ask Gemini to help us write this prompt. So I'm going to switch to the Pro mode. and tell Gemini, okay, so I now need to build an AI agent on Neo4j with a graph and embedding created in the notebook. Okay, so I want agent to query the tweets based on user text, hashtag, and locations. Okay, so help me draft a prompt. Okay, so that's great. So we have this prompt. I need an AI agent. And also the best part is that it tells structure of our data and also suggests some tools like semantic search, also queries, topic queries, and also geospatial queries, etc. Okay, so I'm going to copy this prompt to the Neo4j and let AI to create that AI agent. All right, so now this agent is ready. So you can see they are using our demo instance, and apparently they also use the Google Cloud Computing to host this AI agent, and it gives name and also the prompt instruction so that you are social media research assistant. So this is the access. So if you want to use this one internal, use that one on this Neo4j website, and it is free. So if you want to deploy this one to outside, for example, as an API service or MCP server, so that's where you need to pay for that usage. Okay, so here this is the most important part. Here we can see AI just help us create those tools. So for example, we have this semantic search. So if you click edit, you can see we are using this embedding to retrieve the tweets that match the queries. So that is semantic search. And here we have this large language model to generate Cypher queries. So where you can see that depends on the user's questions, generate a Cypher query to retrieve the information from our graph database. We also define the other queries. So for example, here this is to find out the tweets by user. We can also say that tweets by hashtag. We also can find tweets based on the place information and also enrich tweet details by ID. Okay, so those are the tools that are available that in this agent. You can of course define those new tools, especially like for the Cypher queries. Okay, so let's give it a try. I'm going to ask AI to help me provide some demo questions. All right, so now we have some questions. So first we can test the semantic search. So what are people generally saying about graph database? So let's pass that question. And we can see those are the results. So people are generally talking about graph database as game changers. Many tweets highlight that relational database struggle with joins and but graphs handles them naturally. And also those are the hashtags that are frequently used. So let's look at the thinking process. So that is actually more important. So first, we can see they do a semantic search. So find out all the tweets that match with graph database. So the output will be those returned tweets. And then I think they just do a summary. So they pass all the returned tweets to a large language model and also generate summary. All right, so this time I'm going to try a geospatial query. So my question is, what topics are trending among users located in San Francisco? All right, so here we have this result. We can see that users in San Francisco are frequently discussing topics about AI, cloud computing, Neo4j, and Python. And here are some specific examples. And let's also look at the thinking process. So here, the place name equals San Francisco and also retrieve all the tweets. Okay, so that's very nice. So here I'm going to say that find out the most popular tweets using the hashtag AI and also identify the users who posted them and also retrieve all the recent tweets posted by those specific users. So let's look at the result. So it took 31 seconds. And you can see that the agent does that when they were trying to use a hashtag function to find out tweets related to AI, there were no records returned. So that's why that agent then used a different approach. That is, did a semantic search, so with the keyword of artificial intelligence. And then after the semantic search, they were able to find out the tweets that contain the hashtag of capital AI. Okay, so it looks like I provided lowercase AI, so and then they find out tweets with hashtag capital AI. So that's great. And based on that, the agent is able to find out the 3 most popular tweets containing the AI hashtag. So that's the first one, the second one, the third one. Now we're going to retrieve other tweets that by the same users. So here we have the result. So this user frequently tweet about interaction of AI, cloud, Python and Neo4j. And those are the summary of tweets. In summary, so these influential users located in major tech hubs like New York, San Francisco, and Tokyo, and they are actively discussing about AI and also cloud. That's very impressive. So if you look at the reasoning process, what happened in that 31 seconds, so we can see the agent did use a hashtag search and didn't retain any tweets. So then the agent decided to use a semantic search. And also from those tweets, they find out tweets contains a hashtag of capital AI. So based on tweet ID, they can find out the user information. And then based on user information, they are going to find out other tweets that posted by the same users. Let's just go ahead and also create this agent. All right, so here you can see my second agent is now published. So you can just use this one for free within the Neo4j website. You can also continue adding more tools and also fine-tune the prompt. So, and that's how you build a fully functional GraphRAG agent in Neo4j without writing any code. So by setting up these instructions, we have handed the workflow over to the AI. It's now determining when to use our embeddings, when to apply filters, and also how to navigate the graph to retrieve accurate answers from our tweet data. We can also see how Chrome Gemini features can save time by understanding our code and also translating our Python code into the exact prompt that agent requires. So if you want to find out how we initially set up the database or generate the Gemini embeddings, I have the link of the previous tutorials in the description below.